So these are examples that are on the photostated sheet I gave you. So more examples. I don't have them here on the screen, so I'll have to read through them. They say a car battery has an EMF of 12 volts.
Oh, ma'am, I think that the answers are given there next to the questions.
Yes, but we need to get to the answers. Okay? We need to get to the answers. They say a car battery has an EMF of 12 volts. So that's the curly E. They say that the internal resistance of the battery is 0.01 ohms. And they say that the battery produces a current. So the current is 10 amperes. This is the information that's given. So the first question of example 1 says, calculate the terminal potential difference of the battery. So you could say V terminal, or you could say V external. Good. What equation can we use? What is there on your data sheet that you can use?
The curly E equals to the V external plus the V.
Okay, EMF is V external plus VR. Okay, so that's another way to give you the lost voltage. Okay, so do we have the EMF? Yes, it's 12. Do we have the V external? No, we don't have the V external. Can I get the VR?
Yes, by calculating the volts of the battery.
By taking the total current and multiplying it by the internal resistance. So sorry for taking more steps now. So V external, 12 is V external plus, what's the current? 10. What's the internal resistance? 0.01. And you do your Cassiophication there, and you should get the answer that's on the screen there. Just check that it is the case. $11.9
Yes.
volts. So we've answered A. B asks us to calculate the R external. How will we get the R external?
The M equals to the current times the R external plus the current times the.
Do you have to use that part? Can't you just use Ohm's law? I don't have to rewrite the EMF is equal to the external voltage plus the lost volts. I can use Ohm's law. What will R external be? It will be V external, yes, divided by I. Will it be the total current? Yes, it's the total current that will flow through the circuit. So our V external is 11.9, and the total current we were given, it is 10, and that will give us 1.19 ohms. Number C, I'm sure you'll be able to determine the potential difference if the battery produces 100 amperes. So what has changed? What has not changed? The EMF can't change. It stays 12 volts. And the internal resistance stays 0.01 ohms. Now they tell you the current has changed to 100 amperes. Calculate the external. That's what you have to do here. I'm sure you'll be able to cope with this now. Okay, so I'm using the external is the EMF minus IR. The EMF is 12. The I is 100. So it's 100 times 0.01. So it is 1. Am I right? That gives us 11 volts. What's happening to the voltage? It's decreasing when the current increases. The big question is, why would the current increase like this? What must happen in the circuit to increase the current? The resistance must decrease. Okay. So question D says, explain why the lights of the car dim when the car is started while the lights are on. So, explain why. The lights dim when you start. The car with lights on. Yes.
Isn't it connected in parallel?
Isn't what connected in parallel?
The circuit of the car.
So what in the circuit is mentioned here?
So the current is divided with the...
Yes, but listen quickly. What is connected parallel? The what and the what? What starts your car? A starter motor. A starter motor. And the... Come? The lights. The starter motor and the lights are connected parallel. You're right.
Because you're adding another resistor, like you add, like switching.
But look at what's happening to the current. You didn't know it. The current increases. So why would the light dim? Lights dim if the current increases.
So what's the answer?
You started off with the correct concept. The starter motor and the lights are connected in parallel to the battery. Am I right? Because the battery is supplying this voltage. Okay? So when you turn the key in the ignition, what are you doing? You are connecting the starter motor.
Yes.
You are connecting the starter motor parallel to the lights. What's going to happen to the resistance in the circuit? it's connected into the circuit. What's going to happen to the total current?
It will increase.
Yes, because the total resistance decreases and the current is, according to Ohm's law, inversely proportional to the resistance, the total current in the circuit will increase. So why is the lights dimming? If the total current is increasing, why is the lights dimming?
Well, that's good because the current is split and shared.
Remember that from this year on, you need to think of what the effect of internal resistance is. And dimness is determined by power. Dimness, the dimness or the brightness refers to power, which is the rate at which energy is dissipated. I know I didn't have a chance to talk to you about grade 11 work, but we referred to this last year. So power can be calculated. There are a few equations that we can use to calculate power. Okay? So one of them is power is voltage squared over resistance. Now the lights, their resistance won't change. But what is going to change over the resistors, over the lights? The voltage is going to change. Why is the voltage going to change? Because with the current increasing, the lost volts will do what? Will what? The VR, the lost volts, will increase. So what is available to the starter motor and the lights? The V external will what? Will decrease. And the V external is the voltage that is available to the lights and the starter motor, okay? But that's what is available to the lights. You can't see the effect on the starter motor, but you can see the lights will dim. Why will the lights dim? Because the V external decreases. Power is directly proportional to V external squared. So the power will decrease. And that is why the lights will dim. Because the power decreases, it's got a dimming effect on the lights. Ask if you can drive yourself, switch the lights of the car on, put the key in the ignition, switch the lights on, and then you start the motor. And you'll see the lights will dim. While you start it, the lights will dim, and now you understand why.
So then, by turning the starting motor on,
You're closing the parallel part of the circuit.
and you're increasing the current.
You're increasing the current because you're decreasing the resistance in the circuit. So if I can squash it in here somewhere, you've got your battery that supplies 12 volts, and you have your lights. There will be more than one lights, but I'll switch that one on now. Without the key in the ignition, the starter motor will be disconnected. That switch will be open. So you put the key into the ignition, okay, and you turn the key, then it closes that. We forgot about the battery having an internal resistance. So closing the circuit here will decrease the total resistance in the circuit, so it's increasing the current through the circuit. Increasing the current through the battery will cause a bigger lost volts because of the internal resistance of the battery. If you've got a bigger lost volt, the terminal voltage will drop. So you've got less voltage across your starter and your lights. So in our second example, we've got a circuit. They do not tell us whether this 20 volts is the EMF or the terminal voltage. We don't know at this point in time whether it's the EMF or the terminal voltage. Okay? But they do tell us that, oh no, there is an internal resistance in the cell. Okay. So the first part of the question asks us to get the external resistance, the total external resistance. What would you do? Yes, you can. V external. I don't know what the external voltage is.
Or the voltage across and the voltage across the 3 ohm, we can do that.
You can, and then you've got the but you're doing more than one calculation then, because they want the resistance. Do we have all the values of the resistors? Yes. So can't we just go 1 over 24 plus 1 over 8 to the power negative 1 plus 3? Can't we do that? Because it's fine, you can take another path. That is logic to you. But consider the time that you take.
No, I thought that you were answering a C. I don't know if you were starting over from A.
Oh, yes, you know. No, I'm not there yet. What is it? The equivalent parallel resistance. That's what they're asking. Equivalent parallel resistance. So not yet the total resistance. So it's RP. What will it be? Sorry. My humble apology. 6 ohms. Okay. So that is, before you lose marks for not writing the parallel equation, it is 1 over R1 plus 1 over R2 plus R3, all to the power negative 1. Okay. Then B, they ask for the total resistance. Am I right?
Yes.
Total RT, the total resistance. That would be the parallel resistance plus the series resistance. And that would be 6 plus 3, which is 9 ohms. So this question is rather easy. And then number C, they ask for little r. How are we going to get little r now?
M equals to I times R plus the I and R.
Like this.
Yes,
Okay, and the EMF, do we know what it is? Is it 20? Because they didn't tell us that it's 20.
it is 20.
But how can you can't assume it. So
Just quickly to the next one.
so the V external is the total I times R external, RT. which is 2 times 9, which is 18 volts. So I'm going to change this equation, use E equals V external plus IR. That will make more sense to me. Are you happy with me doing that? You can't guess that it's the 20 is the EMF. Now I know that is the EMF. The 18 volts is the external voltage. The current is 2 and R is that. I think your little R works out to be 1 ohm.
Okay, ma'am.
Yes.
What if you had safely assumed that EMF is 20 and then you got into 1? Because I got to 1 also. My internal resistance equals to 1.
Yes, but yeah, you need to take care. You could have used E equals I times R plus I times R. But if you substitute this, you're assuming it's 20. So it's dangerous to assume that it's 20, because say you worked out to have a negative R, what are you going to do then? So be careful. Yes, this question worked out correctly. So 2 times 9 plus twice R, then R will be 1 ohm. I would rather determine the terminal voltage with the information I've got before I assume that that is 20. Anything else here? Okay. So in this example, we've got a voltmeter across the battery with an EMF of 12 volts. An internal resistance is unknown. Ammeter and the resistor is in series to the battery. And the ammeter, the resistor has a resistance of 2,4 ohm. Okay. The first question asks us to draw a circuit diagram. So the voltmeter is connected across the battery, and I'm doing it this way. There's a battery, and the battery's got an internal resistance. Okay? So if you want to, you can draw a little broken line block to indicate that that resistance is internal resistance. There is an ammeter and a resistor. And should I put a switch into the circuit?
No.
Not? Because what are they saying? Don't they say in question D, what will the reading on the voltmeter be if one of the terminals of the ammeter is disconnected? Oh, so I don't have to put a switch in here. All right. I would like to put a switch in there. Okay, so this resistor is 2.4 ohms. That's A. B asks us to, if a voltmeter reads 10 volt, calculate the reading on the ammeter. What would that be then? It would be the terminal voltage. The Vx is 10 volts. The EMF is 12 volts. EMF is 12. What's the reading on the ammeter? E equals V external. Can I do this? No. I can.
You can use the I equals to V as the I.
Yes, I can use, because this is the only resistor in the circuit, am I right? Oh, so this voltage here is 10 volts. You understand what I'm doing?
Yes.
Because it's the only resistor in the circuit. So I can go I equals V over R, and I'll use 10 over 2.4. Okay, what do we get? 4.16 ampere. So technically, 1.7. So this is technically the external voltage and the external resistance. Number C. Use the value calculated in B to determine the internal resistance of the battery. How am I going to get internal resistance?
The same equation, but you say R equals to V over I.
Okay, little r equals V over I. Is that what you'll do?
Yes, ma'am.
But what will your V be then?
My V will be the 2.
Where do you get the
I
2?
subtracted it from the
Ah, so this is the first thing you have to do. You have to say E minus the external.
yes.
Okay, so that is 12 minus 10. So that would be 2 volts. So the lost volts is 2. Okay, so it's 2 over
2 over 4,1.
7. Yes.
Which is 0,48.
Okay. So technically we are using E equals V external plus I times R. That's technically what we are using. Okay, so that is 12, that is 10, this is 4.17, and R is the value that we need to calculate. R is 0.48 ohm. Okay, D. D asks us, what will the reading on the voltmeter be if one of the terminals of the ammeter is disconnected? So the ammeter gets disconnected. If the ammeter gets disconnected, what will you have? Yes, you'll have an open circuit. If you have an open circuit, the V external will become what? I?
The voltmeter is going to read the EMF of the cell.
Yes, it will be equal to the EMF because your lost volts, the VR, will be 0. This will be 0. So your voltmeter will read the EMF when the circuit is open. So your voltmeter's reading will be 12 volts. You're opening the circuit, so there's no current flowing. And if there's no current flowing, there's no lost volts. So your voltmeter will read the EMF. Are you happy with that? So in this example 4, we have a battery with an EMF of 24, an internal resistance of 1 ohm, and then 3 resistors, or 1 6 ohms, or 2 3 ohms, or 3 9 ohms. Which ones are connected parallel? Or 1 and or 2. And then a voltmeter across the parallel combination. In A, they want us to determine the current in the circuit. What do I need? We need the total external resistance. And that would be 1 over 6 plus 1 over 3, all inverted, to get the parallel resistance, plus the series, which is 9. Okay, I'm taking a shortcut, but not by doing everything in one step without equations.
Don't you plus the 1?
Pardon?
Don't you plus the 1, the internal resistance?
No, I'm busy calculating the external resistance. 11 ohms. Okay, so this is 2 ohms. Those two together. 2. Okay. So they want us to determine the current. Then I'll go E equals I times R external plus internal resistance. That is 24 equals I times 11 plus 1. So my I would be 2 amperes.
And I'm not focusing on side.
Yes, it's right. There is more than one path you can take. It's perfect. You could calculate RT there. You could say RT is RP plus the RS plus the R. It's perfect, Sangi. With the circuit problems, there is more than one way for most of them to solve the problem. Okay. So perfect. Then you say E equals I times RT. So you've got 24 equals I times 12. You'll get the 12 there. Okay. So it's 2 amperes. Number B. Calculate the reading on the voltmeter. So that is V parallel. That is I total times R parallel. Okay, so we've got total current. What is R parallel? You say 2. So that would be 4 volts. The 2 comes from here. Okay. And number C. What will happen to the voltmeter reading if R2 is removed? So they take R2 out. So removing R2, will increase the total resistance in the circuit. Yes? What will that do?
Which will increase the current flowing because current is inversely proportional to resistance.
So it increases, no, decreases, sorry.
Oh, yeah.
It decreases the current. Okay. Now, if the current is decreased, what will happen to the lost volts? If the current is decreased, your total current flows through the battery. So what is going to happen to the lost volts? VR will decrease. Okay, now we need to start thinking. If the VR decreases, your V external will increase. Wait a moment, I think I'm rushing over this. So the current through the circuit will decrease, but the V external will increase. What will happen to the V across the 6 ohm resistor then? The total V external will increase. What will happen to the voltmeter reading? what will happen to this voltmeter reading? Will it increase or decrease? So V external will increase, and the voltage of the 9 ohm will do what? So this question has a different angle to the whole thing. Because now the 3 ohm and the 1 ohm will be in series. The 3 ohm, the 9 ohm doesn't change. The 6 ohm, this resistance has changed now. It was 2 ohms, now it's 6 ohms. What happens? We know that the V external will increase. Sorry, it's very late. What will happen to this voltmeter? If I put a voltmeter there, what will happen to it? Will it increase or decrease with a decrease in current? There, the current is less. What will this voltmeter do? The voltage across the 9 ohm will what? With a smaller current. Yes? It will decrease. Am I right? So V external will increase, but the V9 ohm will decrease. So what will happen to the voltage across the 6 ohm resistor? That increases, this decreases, so what? Yes, it will increase. So this was actually a difficult one to answer because it had a different angle to it. But still, you start off with what happens to the resistance. If you remove that, what will happen to the total resistance? What will happen to the total current? What will happen to the lost volts? What will happen to the voltage across the 9 ohm? What will happen to the external voltage? What will happen to the 6 ohm resistor's voltage? So it will increase. This is enough for today. Can you do as homework that exercise 7.1, just number 1? Please. Exercise 7.1, just number 1. Just to practice doing this on your own. 7.1. Thank you very much.